Hello friends, how are you all? I hope everyone is doing great. Welcome to our channel Red's Info Hub. If you are new to our channel, please subscribe our channel and click on bell button and also on like button. Right. In this video, we would like to discuss about basic mathematical tools. In that, specifically about graphs. Are you ready? Let's take pen and paper. Let us start with basic mathematical tools, and that in graphs. But graphs which is used in physics and which is useful for NEET and JEE point of view. Yes, guys. Let us see here. Yeah. See, basic mathematical tools. In this graphs, so do you know what is a graph? So let me tell you briefly about what is graph. Graph is nothing but a geometrical representation of variation of one parameter or one quantity with respect to another is called a graph. Okay. Geometrical representation of variation of one parameter with respect to another, or variation of one quantity with respect to another is called graph, right? You see, this for a standard two-dimensional graph, in general, we can say, usually we'll draw a standard two-dimensional graph by taking two axes, Cartesian coordinate axes. In these two axes, as shown here in the figure, the independent variable will be taken on horizontal axis, we call it as abscissa, and the dependent variable will be taken on vertical axis, we call it as ordinate, whereas the point of intersection of these two axes is called as origin, right? The point of intersection of these two axes is called as origin. Is it clear? This just briefly I would like to give a few an idea about this, a few terminology here. So the next, I would like to tell you that how the straight line graph for a standard equation of straight line looks like. So to understand that, let us look into the standard equation of straight line. What is the standard equation of straight line? The standard equation of straight line is given by y is equal to mx plus c, right? Where m is slope of the line and c is y-intercept. C is y-intercept, right? So here I would like to give you an idea about what is slope. So slope of the straight line. What is the slope of straight line? It is defined as the tangent of the angle between positive x-axis and the line taken in anti-clockwise direction. What is taken in? The angle, where the angle is taken in anti-clockwise direction between the positive x-axis and the line. Or alternately, this slope can be defined as the change in y coordinate with respect to x coordinate. Right? So you can briefly give this as separately. M is equal to tangent of the angle between the positive x-axis and the line, right? Where it should be taken in anti-clockwise direction from positive x-axis, right? And this can also be given as M is equal to change in y coordinate with respect to x coordinate. We can express it as a dy by dx or delta y by delta x. This is nothing but change in y. Dy is nothing but change in y. Dx is nothing but change in x. Okay. So by combining these things, we can rewrite it as m is equal to tan theta is equal to delta y by delta x or dy by dx. That is equal to y2 minus y1 by x2 minus x1. Got it? Here, I would like to give a point as a note that here theta is what? The angle between So if you take a straight line graph, just I will show you the standard straight line graph in the next slide. In this here, just to try to remember that this angle theta will be measuring the angle theta between positive x-axis and the line in anti-clockwise direction, right? And if this angle is less than 90 or acute, we can call this kind of angles as acute angles. What angles? Acute angles. Then the slope m will be positive. Whereas if theta is greater than 90 or obtuse, then the slope m will be negative. Is that clear? So with the help of these points, let us try to understand how the graph of standard straight line equation looks like. That is how the graph of y is equal to mx plus c looks like, and the different forms, the graph of the different forms of this standard straight line equation looks like. The first, directly we'll take it as y equal to mx plus c, where already we have discussed that c is what? Y-intercept, and m is slope. C is y-intercept. So here C is positive. So what you have to understand is this is vertical axis is y-axis and horizontal axis is x-axis, right? So if we are having y-intercept is a positive value, means we will be having y-intercept on positive y-axis. So let us consider just blindly. I will show you here how to draw this also. Let us say y equal to mx plus c is having positive y-intercept. So this is y-axis. So let us take it as a positive value. C is positive value. Okay, fine. Then here slope is also positive. There is no sign, means you have to take it as positive plus mx. We have to take. That means slope is positive. The slope is positive means you have to understand that theta will be less than 90. Theta is the angle between positive x-axis and the line. So if you draw a horizontal line from this point C, so if you try to measure the angle from this positive x-axis, the line will be taken as positive x-axis. So this angle will be 90. So that angle for a slope to be positive should be less than 90. That means should be between this horizontal line and vertical line. So you can say somewhere between these two, like this. So if you extend here, it will be intersecting on x-axis like this. This is x-axis. This is y-axis. Vertical axis is y-axis. So this is how the standard equation of what is that? The graph of a standard straight line equation y equal to mx plus c looks like. That is what we have depicted here. Yes. So this is c plus c, and as it is having positive slope, theta should be less than 90. That's what we are taking here, less than 90. So we are just taking the graph in this manner. Is that clear, everyone? So if theta is less than 90, m is positive, and the graph looks like this. Whereas in the second case, let us see another possible case, that is y is equal to mx minus c. That c is y-intercept, it is negative, means we should have intercept on negative y-axis. Sorry, y equal to mx minus c, right? Yes. So for y equal to mx minus c, c should be negative. That means it should have a negative y-axis, right? So this graph correct in that case? You have to be carefully follow this point. Carefully follow this point. Just here, this is not the graph for this. C should be on negative y-axis, but here we have taken this as on positive y-axis, just to give you an idea about whether just you are following or not. I have taken this graph. Now just to understand a little properly, let me take the next page. So how to draw the graph for this correct graph, I will show you next in the next slide here. See here, mx minus c. Did you understand? Did you see here? Y equal to mx minus c. Y is equal to mx minus c. Did you observe these two now? So here minus c means you should have y-intercept on negative y-axis. So this is negative y-axis, this is positive y-axis, this is positive x-axis, and this is negative x-axis, right? So y-intercept is on negative y-axis means somewhere here, just you can take like here or anywhere. And slope, if you observe, m is positive, means the angle between positive x-axis and the line should be less than 90. So you draw a horizontal line from the point of this is c. This is C for y-intercept. So the line should be between vertical line and horizontal line. That is what you have to understand. And if you draw a line like this and if you extend, it will looks like this. So we'll have a straight line graph of this form as like this. Is that clear, everyone? Next possible representation of straight line equation, let us try to see. Y is equal to minus mx minus c. That means here c is in place of c we are having minus c. That means we should have negative y-intercept. So that y-intercept should be on negative y-axis. So say this is a positive y-axis, this is negative y-axis. This is positive x-axis, this is negative x-axis. So let us let us mark a point on negative x-axis and we mark this as minus c. And here m is also negative. Did you observe this? Negative. That means slope should be negative. So slope to be negative, theta, angle between positive x-axis and the line should be greater than 90. So to understand that, let us draw a horizontal line from this point of intersection on y-axis, and let us take this as y-axis, positive x-axis. With respect to this positive x-axis, the angle should be greater than 90 means, so the angle between horizontal line and vertical line is 90, so it should be more than 90 means the line should be like this, somewhere here, more than 90, okay. And if you extend this, it should be like going and intersecting the x-axis over here. So but the overall the graph looks like this. I hope it is clear for you how to draw this kind of graphs. Graph for minus mx minus c. Whereas if c is 0, y-intercept is 0, there is no intercept, and y and x variables are varying accordingly, or according to the equation y equal to mx. In that case, we can call this y equal to mx is also a straight line equation where c is 0. That means y-intercept is 0. In such case, we can say this is a straight line equation, and the graph of that looks like passing through the origin. Is it clear, everyone? That c is 0 and m is positive. M is positive means angle between positive x-axis and line should be less than 90. So this is positive x-axis. Positive x-axis. This is positive y-axis. So the angle should be less than 90 degrees. Is this clear, guys? Right. Whereas if you take y is equal to minus mx, y is equal to minus mx, here minus m is a slope, negative slope. Slope is negative means theta should be greater than 90. And of course, y-intercept is 0. And when y-intercept is 0, you have to say that the line, straight line is going through origin. And angle between the positive x-axis. So this is positive x-axis and this is negative x-axis. This is positive y-axis, this is negative y-axis. So angle between positive x-axis and the line should be more than 90. So this is the angle between horizontal line and vertical line should be 90. Should be more than 90 means the line should be like this. Is that clear, everyone? Yes. I hope this gives you a brief idea about how to draw a straight line and how the straight line looks like for a standard straight line and y equal to mx plus c, or with y-intercept is 0 also, right? Now, let us see few examples where we come across this straight line kind of graphs in physics. In physics, say for example, as a first example, let us see in Ohm's law. We know that Ohm's law says that V is proportional to I. Potential difference is proportional to current, okay, for a conductor. So V is equal to Ri, where R will be a constant. So here, as V is proportional to I, it is in the form of Y is proportional to X, or this is in the form of I is equal to mx form. M is a constant, so we can write it as by taking this constant as proportionality, and you can write it as y proportional to x. So it is similar to straight line equation. So if you draw a graph between potential difference and current, we'll get a straight line like this. I hope it is clear for you. And also, if you observe in gas equations, you come across this in chemistry also. Ideal gas equation is PV is equal to nRT. In Charles law says that a constant pressure, as N and R are constant, volume is proportional to equal to volume is directly proportional to temperature. So volume is directly proportional to temperature. It is in the form of y proportional to x. So the related graph between what is that here? V is volume, T is temperature, absolute temperature. The graph between volume and volume axis and temperature axis will be a straight line as shown in figure. Is that clear, everyone? And a few more graphs let us try to look into where we'll try to use this in physics. So you see here the VT graph, that is velocity time graph for first equation of motion. We have different equations of motions, right? First equation of motion is V is equal to U plus EAT, and second equation is S is equal to UT plus half AT square, and third equation is v square is equal to u square plus 2as, etc. Here, first equation, if you observe, v is equal to u plus at, where u is v is final velocity, u is initial velocity, a is the uniform acceleration, t is time. So for this equation, if you try to draw a vt graph, velocity time graph, then it looks like this. See here, this you can rewrite like this: v is equal to at plus v, because we want to draw the graph between velocity and time. So v should be independent. Sorry, depending on time should be independent. So we are taking this on time on x-axis or horizontal axis, and velocity on vertical axis. Now, if you observe, if you rewrite this as this t is a function, so here just like x is a function here, you can write it as v is equal to at plus u. And if you compare this with the standard straight line equation, y equal to x plus c, so u is similar to c. So this is constant. Initial velocity will be constant, whereas t is a variable, just like x is variable here, and a is constant, just like m is constant here. So the in place of m, we are having slope. Slope of vt graph gives acceleration. That is one point, very important point you can understand from this. Slope of vt graph gives gives acceleration. I don't want to write more words here, so that it will looks like more clumsy. So you have to just have an idea about this, right? Slope of vt graph gives acceleration. That's what you can understand. Very important point here in this. And if you compare this two, and if you try to draw the graph, how the graph looks like, let us see. So here it is a c. In place of c, we are having u. It will be having some positive value. So let us mark a positive value on v-axis here. That is nothing but y-axis in this case. And a is slope. So it is positive. It is positive means the angle between the positive x-axis and vertical axis should be less than 90. So if you take like this, it should be less than 90. And if you draw a line like this, you get a graph like this way. So this gives you vt graph for the first equation of motion. That is v equal to u plus at. Is it clear, everyone? Right. So based on this, we will come across different kinds of straight lines also while dealing with what you call motion in straight line, different graphs like this kind of graph for uniformly accelerated motion. For a body starting with the what you call zero initial velocity, you will get a straight line graph like this. So vt graph will be like this. Whereas if the body starts with a positive positive initial velocity, then the graph will be getting like this vt graph. So right, so this will be a straight line. But if you extend this anyway, you'll get a graph like this kind of. Whereas few more graphs related to this, say VT graph for uniform motion only. For uniform motion, this VT graph is for uniformly accelerated motion. This one is for uniformly accelerated motion. Whereas VT graph for uniform motion, uniform means u will be constant. And u is constant means acceleration will be zero. This term will become zero. If this term becomes zero, v will be equal to u. That will be fixed. So if it is v and it will be having a fixed value, whatever may be the time, if increasing the time. So it does not depend on time. So we'll get a line straight and parallel to time axis. So this is the vt graph for uniform motion. This is the vt graph for uniformly accelerated motion. Is it clear, guys? So this kind of straight line graphs we'll use in physics. And you can have an idea of how to calculate the slope and what do you call y-intercept if you have given some equation. Let us try to understand with the help of an example here. So the question given here is find the slope and y-intercept of the equation this, and try to draw the graph. So to understand this, let us try to take the same equation. 4x minus 2y plus 4 is equal to 0. And let us try to write this in the form of y equal to mx plus c. Y is equal to mx plus c. If you want, you have to take this out of the some other side of the equality symbol. So if this minus 2y, if you send this side, it will become plus 2y. So let us write it as 2y. Let us write it as 2y is equal to what? 2y is equal to 4x plus 4. So if you simplify this further, 2 2's 2 2's. So y is equal to 2x plus 2. So this is the equation we have got. And if you compare this with the standard straight line equation, we'll get y, that is y equal to mx plus c. Directly you will get the values of a slope and y-intercept. Here c, in place of c, we have what we have in place of c? We have 2. So we directly can write it as c is equal to 2. And in place of m, we have plus 2. So Slope is also positive, C is also positive. So that is how we can calculate C and M values directly. Is it clear, everyone? And how to draw the graph? So just you can take horizontal and vertical axis. You can take horizontal and vertical axis. See here. So let us say this is horizontal axis, and let us say this is a vertical axis. And now, as C is y-intercept, it is positive. So if this is our y-axis and if this is our x-axis, and if we take y-intercept is positive value somewhere here on positive x-axis, plus 2. This is 1, this is 2, let us take. So plus 1, plus 2, and slope is positive. Slope is positive means if you draw a horizontal line here and if you consider this as a positive x-axis, angle between positive x-axis and the line should be less than 90. So should it be between these two vertical and horizontal lines should be like this. Should be like this. Got it? Yes, this is how we have to draw the graph for this. So, but the slope should be equal to 2. Slope should be equal to 2 means change in y coordinates by change in x coordinates is equal to, that means x coordinate also should be 2 here. That's why here you can take the slope here or anywhere. If you take the slope, change in y coordinates by change in x coordinates, will get 2. That is the meaning of it. So I hope it is clear for you guys. This is briefly about what is a straight line graph and how to draw it in different cases. Okay, guys, let us meet in the next another lecture. So and don't forget to subscribe our channel and click on like button if you are new to the channel. Okay, let's take care, everyone. Bye bye. I'm ending the session.